CIT 1121, Module 11, Submodule 3, Types of IPv4 Addresses. We're going to talk about public addresses, private addresses, network address translation, and why we need network address translation with IPv4 addresses. Let's take a look at the differences, and just so we can identify by a number a public or a private IP address. Now, a public IP address is an address that's going to be that is controlled by an organization that will ensure that there's no duplicate IP addresses within the system. So the one around the United States is called ARIN or ITERNIC, and they're going to make sure that your number isn't being used by anybody else. So that is a pretty important thing. Now, here's the thing. Organizations that are not participating on the internet, or if they want to have internal systems, they're not going to use public IP addresses. They're going to use these private IP address ranges. That's why you've noticed that in a lot of times you'll get an IP address that's 10 or 172.16 or something that starts with 192.168. These are the public IP addresses that, the private IP address ranges that are used so that you can duplicate IP addresses. These cannot be used on the internet. Nowhere in the world is there a unique 10 dot something address. It is taken out of that system. Is there an 11? Yeah. 12? Sure. What about 192.169? Sure, yes. But if it starts with 192.168, or it starts with 10, or it starts with 172.16 through 31, it's a private address. So it's not going to be usable through an internet service provider. You're not going to get any addresses for that, and it's something that you, as a network administrator, can use to subnet and put your addresses on devices. Now, here's the thing. If something has a private address, it is not directly connected to the internet. And we're going to spend more time on this later, but a technology known as network address translation is used to translate out your requests for the internet, and it will send information to the internet for you and then translate it back for you also. So you start with an address that is a private address, like a 10 address. So if we look at like network 10 here, network 10, this device wants to get on the internet. No problem. It sends its information to its gateway router that's connected to its ISP, and at some point in time, network address translation is going to take place, and it's going to remove that 10 address from the source, and it's going to replace it with a global IP address that your organization or your home has. It is an address that you can see and you can identify, but it's going to change out your private address into a public address that can be used on the internet, and then it'll go to wherever it is that it's supposed to go to, like this here. And then this device is going to send the information back, and it'll take the public address out, and it'll replace it with the private address and send it back to where it needs to go. And that's what network address translation is going to do for you. In most cases, when you're a network administrator, you'll have routers that'll be connected to internet service providers. Those internet service providers will lease you public IP addresses that will put you in a unique spot in the world, which will allow you to gain access to the internet. And if you have services that you're going to run off of there, those services will be run, and you'll map your DNS to the IP addresses that your internet service provider gives to you. And that's a little bit about how NAT works. More on that when we get into the NAT stuff. It's actually in a different class altogether. Other addresses that we should be aware of, the link local address, and also the loopback address. So the loopback address we talked about in a previous slide, that is nothing more than a check. It's something to use to make sure the TCP/IP stack is functional on your computer. You can use it in a pinging situation, which is the picture that they've given you here. Other link local addresses, they show you something called you see an address here that starts out with 169.254. Now, those addresses are known as what are called APIPA addresses, and now there's a lot of explaining for me to do about what that means. APIPA addresses are addresses that are given to you if, for whatever reason, the interface that you connect to the network, if it doesn't have an IP address configured by you, right, where you go in and you type in the IP address, and it can't get an address automatically through an automatic addressing giving application like DHCP, which stands for Dynamic Host Configuration Protocol, and that's pretty much the product that you use when you've got a computer and you're going to join a network and you don't know the addressing scheme of the network. your client, your PC just shows up at the network and you plug it in, or the wireless configuration is connected and it's like, hey, I've just joined this network. That's great. I have no idea what IP address scheme I'm supposed to use. I'm going to sneeze. Excuse me. We're too far into the video for me to start over. We're going to keep going. So the DHCP client says, hey, I don't know what address scheme we're using. I don't know what network I'm supposed to be. I don't know what my default gateway is. I don't know what DNS server I'm supposed to use. I'll send out a broadcast message. Excuse me, network. If there's a device that's handing out addresses, subnet masks, default gateways, and DNS servers, if one of those machines is available, please send back information for me. And if there's one that's being used there, then it will send back, hey, well, welcome to the network. Please use address 192.168.10.25. Your subnet mask is /24. Your default gateway is 192.168.10.1. And the DNS server I'd like for you to use is 8.8.8.8. And it'll give it all that information automatically just by joining the network. And that device will then be able to participate on that network. Now, if that process fails, you will do an IP config and you will look at your IP address and it will start with this, 169.254. And that is an address that you do not want to see. That means that you didn't directly configure your IP address, and DHCP services have failed you. And instead of you just keep continuously sending out this broadcast message on the network that says, excuse me, network, can I have an address? And not getting one, and then later doing it again and again and again, your computer basically gives up and just gives itself an address that starts with 169.254. So that's where that address comes from. So that's kind of a negative one. If you see 169.254 when you do an IP config, your computer's probably not participating on the network in the way that you would want. So I think that's enough on that particular slide. The last couple of slides, this one talks about the idea of classful IP addressing. Now, there are two kinds of IP addresses. There are classful IP address routing, and then there is classless IP address routing. Now, here's the thing. Way back when, even in like the 90s, they figured out, they're like, you know what, this classful thing is not super awesome. We've got some problems with the way it hands out addresses. For one thing, we can't take Class C addresses and give them out to internet service providers and allow them to then glob these addresses together in a supernet and use subnet masks that are shorter, which would make their routing tables a lot easier to traverse. So they kind of did away with classful routing a really long time ago, but the concept of the classes is still there, and let's kind of go through these. So the classes that you can use for internet routing are classes A, B, and C, sans the specialty addresses you just looked at, right? So, but these are the addresses that you can use. So anything in Class A is quad zeros through 1120. Usually we said 1126, 1120, or 1020 or 126 in this position. This slide says 127, which is really reserved for loopback, but who cares? If the first number in the address is between 1 and 126, it's a Class A address. If it is between 128 and 191, it's considered a Class B. So anything between 128 and 191 is going to be considered a Class B address. Anything from 192 up to 223 is going to be considered a Class C address. So the default masks on those, and something we haven't spent a lot of time talking about, masks, but the default masks are 8 and 16 and 24. So Class A's, big networks. Class B's, medium-sized networks. Class C's, really small networks, no bigger than 256 total addresses in a given network on a Class C. That's pretty small. Beyond that, Class D's, we're going to use these for multicast. So these are reserved for multicasting. That handwriting is getting worse. And Class E's are considered experimental. And we don't use them. So just keep that in mind. So all of the global or globally routed IP addresses or public IP addresses you're going to get are going to start with a number. The very first octet's going to be a number that's going to be between 1 and 223, and those are all the addresses that we use for the internet as it's set up right now. Now, the organizations that control that are listed on this slide here, and it shows you IANA, the Internet Assigned Numbers Authority, and they pass out addresses throughout the world. And you can see the different continents and how they've been sliced up so that we can pass out addresses to each one of those, and everybody will be able to get an address globally. This is for IPv4 and for IPv6.